Hello, everyone. So this is another math counts problem. So we have a state round, a team round questions. Okay. So let's look at the question. It says we have a square, and each vertex is connected to midpoints of its two opposite sides as given. So this is a midpoint. This is a midpoint. This is midpoint. And what's the ratio of QR to PQ? Since we are dealing with the sum ratio, so we don't really need actual like length, right? So we can just pick a number, so we can go with that. Okay, so let's start with maybe like if I start with ones like this, that's gonna be one, that's one, that's one, and that's one. You know, this is a right triangle, so you can use a pi tag, and you can get this hypotenuse as like √5. But at the same time, you know, we are gonna deal with this segment. We are gonna find this piece. I don't want to really work with radicals. So which is why I'm gonna take this guy as maybe √5 instead of just one. Okay, so even if you really want to go with the one, that still works, but I don't want to deal with some more radicals inside. Okay, so let's say these guys are √5. Okay, so these are √5. And if I use the Pythagorean in this case, you know, that will be the square of this will be just 5. And this is 2√5. The square will be 20. And that should be the square of, let's say this is t dt, right? And that's 25. So that will be 5. So dt will be 5. Okay. And but it's not really helpful that much so far. So I'm gonna kind of see like if you have any similar triangles, because I have a lot of like triangles, right? And to see if there is a similar triangles, maybe I should label some angles. So at the same time, we already know like all these guys, I'm gonna call these some different names. So this is √5, like this is √5. And this triangle right here has a leg of √5 and 2√5, and then this is 90 degrees. And this guy has the same thing, and this guy is the same thing. So all of those triangles, like in these corners, are actually congruent because they have two legs are the same. And if you use a pi tag, their hypotenuse will be the same as well. So we have three sides are equal to each other. So which is why they are congruent. So if I want to label their angles, let's do that. I'm going to call this angle alpha, which is the angle that is opposite to the shoulder leg. And this is my shoulder leg. In that triangle, this is the same angle, okay, corresponding angle. And in this triangle, the shoulder leg is right here. So that means the angles right here should be alpha. And in this triangle right here, the shoulder leg is this. So the opposite will be right here. So I'm going to call this as alpha. So that's something. And if I want to name the other angle in those triangles, like if you kind of don't see what I'm talking, maybe it's better to kind of label, like shade those triangles, at least one of them. So let me take this guy, something like this. Okay, and then you have a bunch of like those triangles, like this one and this one, and you have the same thing going on right here, or same thing going on right there. So let's pull those back. So now if you do look at the second angle in those triangles, you know, this guy right here, which is gonna be I'm gonna call that's beta. And this is the triangle, the opposite to √5. So this is 2√5. Opposite angle is gonna be right here. So that means this is beta. And the same thing in the triangle. So this angle will be beta. So we know alpha and beta is add up to 90 because this is 90 degrees. Same thing right here. B is 90. So then this is gonna be alpha and beta, the similar reasoning. Okay, so let me label those. The smaller angle, like the angle that is facing the smaller side is alpha, so which is why this is alpha and this is beta. And I hope that really makes sense so far. So all of these alpha, and then this guy is beta, and I think we are all good, right? So and then this is also alpha, and this is also alpha. So now alpha and like this beta and this alpha is add up to 90 because this is also 90 and this is also beta. At the same time, you know, in this triangle right here, beta and alpha is also two angles in this triangle, so their sum was 90. So which means the third angle right here should be also 90 as well. So let me label this. This is also 90. This is really important because I like to deal with this guy, so which will make this guy is also 90 degrees. But this is kind of two smaller figures, so maybe we should look for something else. So KA was like √5 and CT is √5, which is two equal segment. And then when we use a pi tag, KC was like 5, which is same as DT, and that's same as AT. So KC and AT is 5. So these two lines are equal. These two lines are equal. So which is why this picture right here is actually a parallelogram. So which is why we can say this guy and this guy is parallel. So the angle right here, because we are looking for the QR, like this guy divided by this. So the angle right here is actually same as this angle right here. Okay, so let me shade this in different color. So these guys are equal. So if you know this angle, maybe you can find this angle or the other way around. So far we got all of these, right? But at the same time, I said this triangle has alpha, beta, and 90. And then also the larger triangle right here is also have the same angles. Maybe it's better to like take those separately. I'm gonna call this is X. So we have two triangles. So something like this. This is a smaller one. Okay, so this is 90. I'm gonna call that corner is X. So let's say this is L and this is D. So this was alpha and the other one was beta. And then we already know this is √5. Okay, and then the larger one, let's do that as well. You can pick any of those four larger triangles that we were talking. So it will give us the same thing because they are all identical. So let's take this as C, and this is D, and this is T. So this was alpha, so this is alpha, and the other should be beta, so which is right here. So we know this is √5 based on what we chose, and then this was 2 √5. As you see, the ratio is 1 to 2, okay, for the legs. And I should have the same thing in the other one because these two triangles are similar by angle, right? So if that's the case, like if I call this is X, this is 2X, then the square will be 4X squared plus 1X squared, which is 5X squared, will be square of this guy, which is 5. Then 5X squared will be 5, X will be 1. So that means this is 1 and this is 2. Again, if you don't really get that part, let me write it anyway. So let's say this is like Y. And then let's say this is 2y because we have the same ratio under the triangle. So 2y squared is equal to √5 squared. And this is 4y squared. This is 1y, which is going to be 5y squared equals 5 divided by 5, which is y squared is 1, y equals 1. And if y 1, that's 1, that's 2y, which is 2. And now we got something really nice because this is 1 and this is 2. And now we already know dt was 5, which is we already had this. And this triangle right here and this triangle right here is also identical. So this is going to be 1, that is going to be 2. So good to have those as well. Okay. And what we just need is this guy divided by this. But at the same time, this divided by this is actually same as this divided by this, because this triangle right here and this triangle right here is similar because these two segments were parallel. So the ratio of this to that is the same as the ratio of this to that. Okay, that's one way to say why they are equal. So if you take a look at this segment, so this was 2, the whole piece was 5. So that means this piece will be 3. I will say this is 3. And this guy is going to be 4 because this is 5. So 1 less, it will be 4. Again, the ratio of this piece to this piece is 3/4, but that is the same as this to that because they are similar. So this is one way to look at it. The second way to look at it is using the tangent, because if you take this angle and the tangent of this angle is opposite divided by adjacent, and since we already know these triangles are equal, so that tangent of this will be equal to this divided by that. So that's another way to say why they have the same ratio. And you can go with its tangent ratios as well, which will give the same thing. And there are a couple other ways, but one of the ways I will ask you to challenge yourself, make some parallel lines, like maybe take this point C, make some parallel lines like that, do this such as parallel lines, and see if you can get another way to do this question without really doing this much algebraic manipulation. And the third approach, maybe I would say, use the a bit trick. Okay, so if you remember some of the double identities of like some double identities of the trig like relation, you can use as well, because you know this is alpha, this is alpha. So for this angle, I can take the tangent of 90 minus 2 alpha. If I can deal with this, you know, this is gonna be equal to 1 over something. So I'm gonna let you try this if you have some background about the trig, and then you can use the double angle identities, because we know alpha, so we know the ratio of the tangent, which is like 1 over 2. So tangent alpha is 1/2. So, and then if you can replace this in terms of tangent alpha, then you can find this relation, which is your challenge if you do have some background about the trig identities. Okay, so I hope that makes sense and it was clear. I'll see you in the next video.